Now I mentioned that for linear and quadratic functions, as well as for circles, we need to be able to convert from parametric equations to Cartesian equations and back the other way. So we'll have a look at parametric to Cartesian first, because I think that process is a little bit more straightforward. Now, for linear and quadratic functions, basically you need to do what we just did, which is just solve simultaneously to eliminate the t. You can almost think of the t as like this guy that knows the x and knows the y. It's going to introduce them, and then once they know each other, he can go away and doesn't need to hang around with either of them. And then for the circles, you need a different strategy. You need to use that trig identity that we've seen in our trig unit, sine squared theta plus cos squared theta equals 1. So I'll show you how to do those ones, which are a little bit different in a moment. So the linear ones, let's just launch straight into solving simultaneously here. You can take either equation and make t the subject. Let's pick this one. So rearranging, I can see that t is equal to x minus 1. And now we have to just sub that in to the other equation. Y is equal to 3 minus 2 lots of t, which is x minus 1. So then tidying up, I've got 3 minus 2x plus 2. So y is equal to minus 2x plus 5. So that was quite straightforward, and this is just a straight line. We already know that it has a y-intercept of 5 and a gradient of -2. All right, the quadratic one, similar idea. Let's use the first equation there to rearrange and get it in terms of t. So we can see that t is equal to x over 3. Subbing that into the second equation, y will be equal to 1/2 times x over 3 all squared. Now remember, we've got to square the 3 as well, so that gives us x squared on the top, and on the bottom we've got 3 squared, which is 9, and when we multiply that by 2 we get 18. And that can be written like that, or you could even write 18y is equal to x squared. Same thing. Now working with circles, we need to use a trig identity, and it's the Pythagorean one. And that's why parametric equations I've left till now after we've actually already studied trig. So we need to use this. Now, you may remember how we came up with it. If we draw a unit circle, which is a circle that's just got a radius of 1, and we define any point on the circle as x comma y, and we know that point can move around and sit anywhere, then we can, no matter where it is, drop a line straight down towards the x-axis at a right angle there. And we can define this angle here as theta and say that if this is xy, then this distance must be x, and this distance must be y. And we know the radius of our circle is 1, so that makes our hypotenuse 1. And what that means is that if the cos of theta equals x over 1, then x is cos theta. And if the sine of theta equals y over 1, then the sine of theta equals y. So instead of writing xy, we can actually write this point as cos theta sine theta. We can also say then that if we know that x squared plus y squared equals 1, because Pythagoras' theorem would tell us that it is, we can also say that sine squared theta plus cos squared theta equals 1. So using that, if we're given a parametric pair of equations that look like this, our first step is to, rather than try and get the theta by itself, we don't want to start putting inverse coses or inverse sines in there. Instead, it makes sense just to get the cos theta and the sine theta by itself. So I can say here that cos theta is equal to x over 3, just dividing both sides by 3. And in this equation, I can divide both sides by 3 and say the sine of theta equals y over 3. Now I can reason that if I know that sine squared theta plus cos squared theta equals 1, then subbing in, what is sine squared theta? Well, it's just y over 3 all squared. So I need y over 3, square the whole thing, and cos of theta is x over 3, so I need to square that. And all of that should still equal 1. Now tidying up here, I need to square the 3's that are on the bottom. So I'm actually going to have y squared over 9 plus x squared over 9 equals 1. So if I want to get rid of those denominators of 9, I can just multiply all 3 terms by 9. And that would give me, I'll just write it in the other order, x squared here and y squared here equal to 9. And we know that that will be a circle with its centre at the origin and a radius of 3.